All right, so hey, it's Mr. Nolde again. I have this exponential equation that a lot of students can solve. They understand that to solve exponential equations requires the use of logarithms. The one thing that I see, though, is a kind of just a lack of rudimentary algebra skills to recognize that this 125 is really the same as 5 cubed. So I could rewrite this as 5 cubed to the x power, right? And then over here, I'm adding exponents. So that means that I could have multiplied with a like base and added the 3x and the 1 exponent. So that's one way of doing this. 3 times x, if I use my power rule, gives me 5 to the 3x. And then we'll have a 5 to the 3x over here. Still times 5. 5 to the 1 is just 5, divided by 200. All right, so we notice you have two common terms here, common factors. You have 5 to the 3x and 5 to the 3x. So we could factor that out, or undistribute it, if you will. So 5 to the 3x times 1 gives 5 to the 3x. So this is another somewhat complicated piece. The 3x, 5 to the 3x comes out here. The only factor remaining is the 5. So that equals 200 still. So what is 1 plus 5? Well, that is 6. So I'd have 6 times 5 to the 3x equals 200. So I want to get after this x, so what we need to do is divide both sides by this 6 here. So that would give us 5 to the 3x equals 200 divided by 6. That simplifies, doesn't it? To 100 thirds. So maybe a quick and easy way to deal with this is to recognize I have a base 5 here. So maybe I'll take the base 5 log of each side. So that would be log base 5. And then I would do a log base 5 over here. So what the logarithm does for us is it releases the exponent. So that ends up becoming 3x times the log base 5 of 5. And that's equal to the log base 5 of 100 thirds. All right, so the log base 5 of 5, that's another property of logarithms. That just equals 1. So 3x times 1 is our 3x. So we'll have 3x equals log base 5 of 100 cubed, or 100 thirds, sorry. So I would now multiply both sides of this equation by a third. So I'd have that my x equals 1/3 log base 5 of 100 thirds. Put a parenthesis there. So that is a short way of solving this. Is this the only way to solve it? No. In fact, I'll show you 2 other ways to solve it. So stay tuned for a moment. All right, so another way is to not use log base 5. You could start the same way we did, but then just use logarithms. So I would still write this as 5 to the 3x plus 5 to the 3x times 5 to the 1. And that's equal to 200. All right, so same as before, factor out your 5 to the 3x. Oops. That's going to leave us with 1 plus 5. And that's still equal to 200 over here. So divide both sides by 6. We'd have 5 to the 3x equals our 100 thirds again. So what happens differently is we could, and the answers are going to be equivalent, but they're not going to look the same. So I could just take the common log of both sides of this. Right? We're allowed to do that. So that releases our exponent. So that leaves us with 3x times the log of 5, common log of 5. And that equals the log of 100 divided by 3. Well, that's the same as the log of 100 minus the log of 3. So that's the step where it gets a little bit different. So a common log of 100 is just 2. So we would just be able to write a 2 in here. And common log of 3, just put common log of 3. Over here, I'd still have a 3x and common log of 5. So we're going to divide by the 3 and the common log of 5. So that leaves us with our x here, and we're going to divide both sides by 3 times the common log of 5. So this answer looks a little bit different than the answer we had before, but they're equivalent. If you typed them both into your calculator, you'd get the same decimal approximation. The other thing that we could have done is instead of taking common log on both sides, we could have taken the natural log on both sides. So that would change it up still further. If I had taken the natural log of both sides, let's go over here and say the natural log of 5 to the 3x, and that would be equals the natural log of 100 divided by 3. So the one thing that doesn't happen here is I don't have a common log of 100, which is 2. I have just all natural logs in here. So I'm going to bring this exponent down, the 3x, and then it becomes times, let me make this look a little fancier, equals the natural log of 100 divided by 3, right? Then, whoops, I forgot my 5 in here. So now I'm going to divide by 3 in the natural log of 5. Like over here, I divided by 3 in common log of 5. So that's going to leave us with the natural log of 100 thirds all over 3 natural log of 5. So go ahead, take a minute, type these both into the calculator, type the first one into your calculator. You'll find out that they give you the same decimal approximation. So there's 3 different ways for you to do what is not a hard equation to do. That's why I said hard in quotes, but it requires some good algebra skills. So algebra skills are important. One of my colleagues used to say, when you get to precalculus and calculus, you find out if you're any good at algebra. So anyway, that's it for today. This is Mr. Nolde signing out. Remember, math is not a spectator sport, so if you want to get good at math, you have to do a lot of math.